Now for this example, I'm going to need a couple of other namespaces. Let me drop them in here. We're going to want to be able to see what threads our code is running on, so I need some things from System.Threading. And this System.Concurrency namespace is necessary for managing the concurrency of observable queries, and we'll see that in just a second. Now, in order to tell that things are actually running on different threads, I'm going to have to do something to show what threads a particular piece of code is running on. So for our main thread, the main part of our program, I'm going to output a formatted string with what's called the managed thread ID. And that's why I needed System.Threading up here. So all I'm going to do is output thread and the managed ID number of the thread that we're actually running on. The reactive extensions give us a number of ways of managing the concurrency that our observable queries are executed on. In other words, the multi-threadedness of them. And we're going to look at one of the most simple ways of doing it. Well, one of the things you can do very easily is tell the reactive extensions that the method you tell it to use, in this case console writeLine, to process the results of the link query to run on a different thread than the main thread that the subscribe was done on. And that's pretty easy to do. So let's go and do that. I'm just going to copy this code because I want to make a new observable query. And let me get rid of this var here. We don't want that. We're just going to clobber what's in this variable right here with a new observable query. And the way we tell the reactive extensions that we want to have our callback function, that is the method that processes the results of our query, run on a different thread, is to use the scheduler class. And the scheduler class comes from this System.Concurrency namespace, and it has a number of static properties that allow us to tell the reactive extensions how we want this callback function run. And I'm going to say I want to have it run on a new thread like that. So that takes care of one problem. What that means is this console writeLine will be run on a new thread, not the thread that we issued the subscription on. However, we need to do a little bit more work to actually see that happen. We won't be able to tell this is running on a new thread because it's just going to output the number, and that won't be very exciting. So let's replace this callback function with a new function that will output a formatted string that has both the number and the managed thread that console writeLine was called on. So we'll add another static method here, static void, and let's just call it process number, because that's what it's doing, and we'll take an int number as an input here. And then all we're going to do is do our console writeLine right in here. And now we're going to go and make a formatted string. So we'll output whatever the number is first, and then we'll output the thread ID. And I'll try and spell thread correctly like this. So I'll put in number here, and here I'll again use that thread .current thread .managed thread ID, like so. So now the process number function outputs this string that tells us both the number that we processed and the thread that processing was done on. We still have a little bit more work to do. We've got to replace this with our new callback function, process number, and we're almost there. Assuming that this actually works, and that is that process number gets run on a different thread than our main program, what's going to happen if I execute this code is it's just going to fall right off the end, because subscribe is going to complete virtually instantly, and then it'll try and execute the next instruction, which we can't see, which is really an exit from the program. And that will happen before this stuff on these other threads gets a chance to run. So let me go put in a console.read key to prevent the program from terminating before we get to see the output. Now we have all the things we need. So let's go and give it a try, Control F5. And now you can see here is our initial for each loop. Here is our initial simple observable query where we didn't specify anything about what threads things should be run on. And here's the one where we said we wanted our callback function to run on a different thread than our main thread. Our main thread is 1. We can see that up here. And the first number, the callback function, was executed on thread 3, then thread 4, because we said we want a new thread, and we got a new thread each time. And then we got to I'm done. Okay. So the purpose of this example is just to show that the reactive extensions give us a way to manage concurrency in our observable queries or any kind of observable object. And this is the most simple we can do, that is to specify where the method that processes the output of the query, that is the callback function, what kind of thread it runs on.